Hello guys, welcome to Ramta Solutions and welcome to your grade 12 probability past papers. Today on our fifth video, we are looking at a paper that was written by the Free State Province in September 2022. So without any waste of time, let's open the paper. So we hear what the nation's best performing province is. Okay. All right. As is the case, we will read instructions. In this paper, I'm going to look at instruction number 3. Is it 3? No, I'm going to look at instruction number 4 that says, clearly show all calculations, diagrams, graphs, etc. that you have used in determining answers. Instruction number 5. Answers only will not necessarily be awarded full marks. Instruction number 7, if necessary, round off answers to 2 decimal places unless stated otherwise. I guess with probability, there's only one formula that is used, so I won't read instruction number 9 that says information sheet with formulae is included at the end of this question paper. But generally, for most of the formulas that you have, please refer to this formula sheet. Okay, so without any waste of time, let's check what this exam went like. So let's see. Remember, probability is normally question 10, 11, or 12. So let's see what it was this time. And I forgot to mention this. We must thank SA Papers.co.za for this clean paper. Okay, let's thank them for this clean. Okay, so let's go now. Question 10, no. So, this one will be in question 11. So guys, this is the 5th video. So since this is the 5th video, I'm going to try to limit explanations there and there, but because the intention of this video is to assist you and to help you understand further what these things are about, I guess it'll take a bit longer with explanations, but where possible, I won't waste time. Okay. All right, question 11. Let's go. Question 11. Right, it says A and B are 2 events in a sample space. Probability of not A is 0.5 and probability of B is 0.35. Determine the probability of A or B if A and B are mutually exclusive. So 11.1.1, we need to know probability of A is equal to 1 minus probability of not A. So what is this? This is 1 minus probability of not A is 0.45. So this is 0.55. The question is asking us to look for probability of A or B. We know that it is equal to probability of A plus probability of B minus probability of A, and ever this question says the events A and B are mutually exclusive. We just said probability of A is 0.55, probability of B it's given to us as 0.35. Probability of A and B, because they are mutually exclusive, is 0. Now our answer is 0.90. That is our answer. Okay, our answer is 0.90. Now 11.1.2, determine the probability of A and B if if A and B are independent events. So we are only looking for probability of A and B. So we know probability of A and B, if A and B are independent, will be probability of A times probability of B. So what do we say? What is probability of A? It is 0.55. What is probability of B? It is 0.35. Okay. So let's see, 0.55 times 0.35. What is our answer? Our answer is 77 over 400. You can write this as 0.1925. Because we leave our answer correct to 2 decimal places, it will be 0.19. Okay, it will be 0.19. Okay, perfect. Now, question 12, 11.2, not question 12, 11.2 says, a classroom has 14 black chairs and 8 red chairs. All right? Okay. Now, during the day, 2 chairs are randomly removed for a meeting in another classroom. Okay, so here we need to be careful. So this is red. Oh, sorry, let me begin with black. Yeah, this is black, and then this is red. So we have how many black chairs? We have 14 black chairs. What is the total? 14 plus 18 seems to me it's 32. So it's 32 chairs in total. So there are 18 red chairs of the 32. Therefore, when you remove one, it's still red, black, red. So if you remove one of the black, you are left with 13 of the black. Total now has decreased to 31. You remove black, you didn't remove red. So the red remains 18 over 32. Again, black, red. You're still left with 14 because you're removing red. 14 over 31, you remove the red, so the number of red decreased. It is 17 over 31. Possible outcomes are black, 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 red, red, black, and red, red. Now, 11.2.1, determine the probability that both taken chairs were red. So in other words, we're looking for the probability of red, red. What is it? It is 18 over 32, okay, times 17 over 31. Red, okay, let's go. 18 over 32 multiplied by 17 over, what is our answer? Our answer is 153 over 496. You can leave it here or you can put it as a decimal. If you put it as a decimal, it will be 0.31. Okay, it's totally up to you. All right, perfect. Now, 11.2.2. What is the probability that a black and a red chair were taken? Probability of black and red. So let's go back to the tree diagram. Black and red is BR and RB. They are not saying black chair first and a red chair after. Or they're not saying a red chair first and a red and a black chair after. They're saying probability that a black and a red chair were taken. So we are going to say probability of black and red is basically probability of black, red, plus probability of red first and then black after. What is this? Probability of red first. I think red was 14. Eh? So it's 14 over 32. Red will be 18 over 31 plus blue. Red first, it's 18 over 32 multiplied by 14 over 31, isn't it? Am I telling the truth? 14 over, yes, I am. Okay, yes, 14 over 32 multiplied by 18 over 32 over 31. Yeah, okay, there's a mistake here that I made. Let's fix it. It's 31, 32. Okay, so it's fine. All right. So yes, this is correct. Okay, this is correct. Now let's go. I feel like this is 2 times 14 over 32 multiplied by 18 over 31. Yeah, I feel like it's 2 times. Indeed, it is 2 times. So our answer is 63 over 124. So this, if you like, 124. This, if you like, it is 0.51. You can leave it here, guys. You don't have to leave it as decimals. Okay, it's okay even if you leave it as a fraction. Whether you leave it as a fraction or as a decimal, it's okay. All right. So this is it. This is the probability that a black and a red chair were taken. It is 0.51. Okay. 11.3. 11.3. In how many? Oh, 5 boys and 5 girls go to the movies. 5 boys. Okay, 5 boys and 4 girls. Okay, so this is a total of 9 people. All right, this is a total of 9 people or 9 kids. All right, they are all seated next to each other in the same row. 11.3.1. In how many ways can the entire group be seated in the row? Here, the order is not important, so we have 11 factorial ways of ordering them. So what is, 9, not 11, 9 factorial ways of ordering them. So what is 9 factorial? 9 factorial is 362, 880 ways of these kids. Okay, 11.3.2. 1 boy and a girl. Ooh, interesting. 1 boy and a girl. Are you guys following? 1 girl and a boy are a couple. Okay? 1 boy and a girl are a couple. Interesting. So 1 boy and a girl are a couple and want to sit next to each other at any end of the row of friends. In how many ways can the entire group be seated? Ooh, remember guys, you have left, they want to sit at the end of the row. So you have left end, okay? So if you have left end, let's say blah, 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 right? So for the left end, these, I think I have to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is the couple. Yeah, this is the couple. Let me just say the couple and couple. So it's 2, 1. And then what is happening? They want to sit at the left end. What are we left with? We are left with 7, right? Because 3 is at 7, 6, 5, 4, 3, 2, 1. Do you guys see that? So for the left end, we will have 2 factorial times 7 factorial, right? For the right end, we will have it's still that couple, right? So it's 2 and 1. So here it's 7, 6, 5, 4, 3, 2, 1. What is this? It's still 2 factorial times 7 factorial. Right, it's still 2 factorial times 7, right? 2 factorial times 7 factorial. I think it's 50, 40. Yeah, it's 50, 40. Oh, no, it's not 50, 40. It's 10, 0, 80. 10, 0, 80. It's 10, 0, 80. Yeah, it's 10, 0, 80. Because 7 factorial is 50, 40. So this is 10, 0, 80. Therefore, we have, I can say we have 2 times 2 factorial times 7 factorial. What will this be? It will be 20,160. Let's confirm. 2 times 2 times 50, 40. Alright? So if you like, guys, you can add these together. You can say, it is this guy plus this guy. It's the same thing. What I did here is the same thing. Okay. Okay, let me write it in a different color. Or you can say it is 2 factorial times 7 factorial plus 2 factorial times 7 factorial, which is 20,160. Okay. All right, moving on. If all friends are seated randomly, let me go to the next page. If all friends are seated randomly, calculate the probability that all girls are seated next to each other. Calculate the probability that all girls are seated next to each other. So here, the sample space highlight this, all friends are seated randomly. So the sample space, which you call n of s, will be 9 factorial. Okay, now our event, okay, for our event, all girls seated next to each other, which we call n of e, will be, let me say, girls next to each other, girls next to each other, girls next to each other. Okay, girls next to each other, we're going to call it n of e. It'll be, how many girls do we have here? We have 4 girls. All right, so if you have 4 girls, they become a unit. Now, these kids can sit however randomly. You have 4 boys, all right? You have 5 boys, and you will consider the girls to be a unit. So you have 4 boys. In addition to that, you have a group of girls who should sit next to each other. So this will no longer be 5, but 6 factorial, right? 6 factorial. Therefore, the probability of this event is, of course, you know your formula of probability. What is it? It is 4 factorial times 6 factorial over 9 factorial, isn't it? Over 9 factorial. So let's go. 4 factorial times 9 factorial over 9 factorial. Sorry, times 6 factorial, not 9, times 6. Answer is 1 over 21. All right, our answer is 1 over 21. This is the probability that girls are seated next to each other. All right, this is the probability that girls are seated next to each other. And this is how you attempt this question. Okay, guys. So this is it. Remember, if you would like to get in touch with us, you can visit our website, www.arametasolutions.co.za. And you can send us an email if you want, perhaps say you're looking for a tutor, or you want us to help you to get that distinction. You want special attention, we will assist you. Because you are watching this video on Facebook, on YouTube, in fact, you can subscribe to our channel. If you have enjoyed this lesson, you can also like and share with your friends. You can, in addition, you can follow us on your favorite social media platform. Okay, guys? So with that being said, ours ends here, and all the best with your examinations. And because this is from the Free State, let me say it ka Sesotho. Le ngwaleng hantle dihlahlobo tsa lona. Bye bye.